Okay, we can start construct the shear force diagram because you already have this value, but maybe we can calculate the bending moment diagram first. So the bending moment value, so from A to C, so at x equal to 0, so what you got just now is this one. Okay, so you put the value, so m, maybe you could say as m 0, or you can just put m. So it is equal to 22.5 x square, 22.5 x square kilonewton m. So if you put 0, so it will be equal to 0, and then at x equal to 2.4, so m, let's say m1 is equal to minus 22.4, x is 2.4 square. So you will get this as 129.6 kilonewton meter. And then from a C to D, at x equal to 2.4, you got m2, which is, you take this equation, so m2 is equal to 129.6 minus 108 times 2.4. You put this value into the equation, into this equation. Okay, so you place this with x 2.4, so you get this equal to minus 129.6 kilonewton meter. And at x equal to 3.3, so you get the moment equal to 129.6 minus 108 times x is 3.3, and you get this as minus 2 to 6.8 kilonewton. And then from D to B, at x equal to 3.3, m is equal to, so m for this D to B is this one. So you put the value of x equal to 3.3 to here, to this x. Okay, so this is x. So it is equal to 305.1 minus 153x. So 305.1 minus 153x. X is 3.3. So you get this one as minus 199.8 kilonewton. And then at x equal to 4.8, you get m is equal to 305.1 minus 153 times x, which is 4.8, equal to minus 429.3 kilonewton meter. Okay, so now you already have all the value, which is V, or maybe you can write in here, V first is equal to 0, and then equal to minus 0.8, and then equal to 1.08 kilonewton kilonewton, and also V equal to 153 minus 153 kilonewton. So this is from A to C, and then this is C to D, and this is D to B. Okay, and then similarly for this is for shear force, this is for bending moment diagram. From A to C, M equal to 0 kilonewton meter, and also minus 129.6 kilonewton meter. And then from C to D, M is equal to minus 129.6 kilonewton meter, and then you also have minus 226.8 kilonewton meter. And then from D to B, you have M equal to 305.1. Oh no, you have a 199.8 kilonewton meter negative, and then you also have moment equal to 429.3 kilonewton meter. So this is all the summary of the value that we have calculated here. So this is the value that I took from here, 0, 129, 129, 226, 199, 429. So I write all this value into here. So now we are going to construct the shear force diagram and bending moment diagram. So this is 0. This is 0 value of shear force. Okay, so from A to C, because it is a UDL, because it's a uniform distribution load, so this uniform distribution load will cause an incline shear force diagram. So it is either inclined like this or inclined like this. But because you got this from A to C, this one is equal to 108 minus 108. So definitely it will be declining downward like this. So that's, let's say this is 108 minus. So C is here. So this should be like this. Okay, and then no, I'm sorry, it should be, because wait, how to erase? Okay, because this is this is the uniform distribution load. Oh yes, so it is because it is. Yes, it is right. Because it is uniform distribution load, so in shear force diagram, it will be inclined like this. So it is right, yes. So and then from C to D, because there is no any force acting here, no force acting here, so it will be constant. So this is D. So it will be constant. So that's why you got also from C to D. This one is also 108. Same to this. So you get a straight line for shear force because there is no force from C to D. So that's why you got straight line. And then from D to B, you got this is one because you have 45 kilonewton here. So and then when you got 153. So you have maybe 153 is here, so you have one value in here. So when you give force here 45 kilonewton from here, so it will go down. Okay, and then because from D to B there is no any force acting, so it will become a straight line for the shear force. Okay, so you got this region. So this is your shear force diagram. And then your moment bending diagram. So let's say this is 0 value of moment bending diagram. So this is 0. Okay, so from A to C, because from A to C, it is a UDL, it is a UDL, a uniform distribution load, it will cause the bending moment diagram to be a quadratic shape, either like this or like this. Okay, but because it is negative, so it is definitely starting from 0 to become negative. So it is like this. So from 0, it goes down to 129.6. So let's say this is 129.6 kilonewton meter. So point C is here. So let's say this is 129.6. So it will be a quadratic curve. So it is a little bit tricky to draw. So it has to be quadratic here. Okay, I will show you the answer. Okay, from this slide later, but it is supposed to be like this. Yes, from here to here it's supposed to be like that. Okay, and then from C to D, you got 129.6 as well, which is here, and then it goes to 2 to 6.8. So it goes to 2 to 6.8 because from C to D it has nothing, so it will go straight for the moment. It will go incline because it is a constant straight line for the shear force. For moment it will go incline, either like this or like this, but because it is going down to 2 to 6.8 minus, so of course it will go down like this. So this is C, so it will go straight to here. This is 2 to 6.8, and then from D to B it will go down to 199.8 kilonewton meter. So there is another one with this one. This is oh no, it will, because this is 199 and this is 2 to 6, so it will go up. It will go up. Not this one. It will go up. So this is 199.8. So it will go up. And then 4 to 9.3. And then it will go down to 4 to 9.3 at point B. So this is, you go down further, this is 4 to 9.3 minus. So the 4 to 9.3 minus is here. So from here, it will go down here. Okay, so that this is the bending moment diagram. Okay, so the answer is like this. So that is how you get this answer. So my drawing for this curve is not really good. So it's supposed to be like this. It's supposed to be like this. So that's why actually from here to here it is a curve. It's a quadratic curve. Okay, so you solve problem question A, and then now you solve problem question 2. So question B. So question B, so the normal stress is equal to MC over I, or it is equal to M over S, because this one is equal to 1 over S. So from the appendix, maybe this question it has appendix, so the S is equal to this value. Okay, so for a moment to the left of point D, to the left of point D, because the question want you to the right and to the left of point D. So to the left of point D, it is equal to, moment is 226 point, C to D is 226 point, you take this value, 0.8. So it is equal to the left, this is left, 226.8 times 10 to the power of 3 Newton meter over S is 2.08 times 10 to the power of minus 3 meter square. So you get this value is equal to 109 MPa. And then to the right of point D, so to the right of point D, the moment is equal to, this is D, the moment is equal to 199. Before is 226.8, it's this one. So this one is 199. So this is equal to 199.8 times 10 to the power of 3 Newton meter over 2.08 times 10 to the power of minus 3. So you get 96 MPa.